Part 2, this is for questions 7 to 11. Question 7, the diagram shows the curve, this one here, and its minimum point, M, where x is equal to alpha. Show that alpha satisfies this equation. Now we can see alpha again expressed in terms of alpha. That means the only way we can solve such an equation is using numerical methods. So the next parts of the question, expect them from numerical solutions. Now, a minimum point is a stationary point. They have given us we call it the nature of the turning point. Now, what some students do and mess up, they differentiate 2 times. You differentiate the second time because you want to look for the nature. Here they have already told you that it is minimum, okay? So it is a stationary point. You just have to differentiate and then equate to what? To 0, not so. So you know that for stationary points, then dy dx has to be equal to 0. Now you know that when we differentiate an exponential function, all we need to do is to get the function, we differentiate it, and then we multiply all through. As simple as that. So we shall need to apply that one somewhere. So what are we going to have here? Our dy dx shall be equal to, this is a product of 2 functions, the algebraic function and then the exponential function. So we use product rule. Keep this one constant, then differentiate the exponential. Then next, keep the exponential function constant and then differentiate the x. That is using product rule. Then you also differentiate this one here, 5, then you differentiate that x. Okay, so what do we get here? When I differentiate this, just like what we said here, you are going to get a 2. Then that 2 multiplied with that function. You see that? Then next, you differentiate here, of course you get a 1, so we get e to the power of 2x, and maybe times 1. And then here we shall get 5, of course, times 1. Okay, now because the x coordinate here is alpha, I will say for now our x, which is equal to alpha, then our dy dx is going to be equal to what? To 0. So wherever there is x, you put alpha. So we shall have 2 alpha, then e to the power of 2 alpha, then plus e to the power of 2 alpha minus 5, then this one is equal to 0. Okay, then we are having this alpha here, this one and this one, so one is made the subject of the formula. Okay, and since I'm seeing a natural log here, remember we use a natural log when we are undoing exponentials, so that means the one that has gotten an e is the one that was made the subject, not so. But now e to the power of 2 alpha here is common, so I can factorize it. I put e to the power of 2 alpha, then here we have 2 alpha, then plus a 1 here. Okay, then of course I will take the 5 this side and then it becomes a positive. Then take this one this side, we shall have e to the power of 2 alpha, then shall be equal to 5 out of 2 alpha plus 1. Then to eliminate this exponential, I'll introduce logarithms, not so. 2 alpha here, then will be equal to the natural log of 5, then out of 2 alpha plus 1. Then after that, of course, using rules of logarithms, this one will come down here. We have 2 alpha, then the natural log of e. But natural log of e is the same as log base e and then e. If the power and the base are the same in a logarithm, then we get a 1. So natural log of e gives you a 1. You can even prove that on the calculator. Natural log of e. Okay, then don't you get a 1? That's a 1. Okay, now let's continue. This one is natural log of 5, then out of 1 plus 2 alpha. So I want to keep this one like the way it is there. Okay, so whether you have 2 alpha plus 1 or 1 plus 2 alpha, it's all the same. So that means our alpha is therefore going to be equal to, you divide all through by 2, so it's a half, then the natural log of 5, then out of 1 plus 2 alpha, and that is that. Part B, verify by calculation that alpha lies between 0.4 and 0.5. Now suppose I have my curve here, and maybe it was coming like that. So this is where it is cutting the x-axis. So that means where it is cutting the x-axis, that is the root, okay? But we have an x value maybe on the left, and we also have an x value on the right. Now you can see that if I get the x value here on the left, this one corresponds to a y value that is up here. And we know that y is positive above the x-axis. So here we are seeing a positive y value. And then this one here corresponds to a y value that is this way, which is a negative. You see that? So that means when we get two values, okay, if a root lies between those two values, then those two values must give different signs when we substitute them into the function, okay? So what we are going to do, we go back to our equation, okay? Our equation is this one here. Alpha is equal to this. So to get a function, bring this one this side or take this one this side, and then you get a function. So you do what you want, okay? But now putting everything on the left, remember it is alpha, which is equal to a half, then the natural log of 5, then out of 1 plus 2 alpha, okay? I will bring this one to this side. So the main fact, just duplicate this, put it here, and then I make this one a minus, just like that, then is equal to what? 0. That means my function in terms of alpha is going to be this one here, just like that. You see that? Then we get f of the 0.4. So wherever there is alpha, I'm going to put 0.4. Then also here minus a half, then the natural log of 5, then out of 1 plus 2 times that 0.4. Okay, what do I get? Then I also do the same for 0.15. Then this one will be 0.5, then plus, it's a minus a half, then the natural log of 5 out of 1 plus 2, then times the 0.15, like that. A common mistake done by students, they come here and then they put the 0.4 here and also the 0.5. You are not going to see a change of sign. Please put everything on one side and then you form a function. Are we there? Then you substitute, you will be in position to get the change of the sign. And I said this one can come this side and you have this minus alpha, no problem. Or this one that I'm having. Okay, now let's put everything in the calculator. 0.4, then minus a half, I'm just going to write 0.5, then natural log of 5, then out of 1 plus 2 into 0.4, like that, and then we get negative 0.1108, negative 0.11, then 0.8, and the rest of those figures, I don't need to write everything. Then how about here? So wherever there is a 0.4, then I'm going to put a 0.5, okay? Even down here, we have a 0.4, so I put a 0.5, then press equals. So you can see that we are getting a positive 0.04185, 0.04185, and the rest of those figures. Then I can conclude and say, since there is a sign change between f of 0.4 and f of 0.5, then I write this. Then alpha lies between 0.4 and 0.5. Then part C, use an iterative formula based on the equation in part A to determine alpha correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Now, since we have seen that the root lies between 0.4 and 0.5, so you have the 0.4 here, you have the 0.5 here, it is in between there. So it is advisable that you look for the mid value here, and then you begin from there. Okay, you can start from 0.4 as your initial approximation. You can start from 0.5 or any value that is in between here. Okay, no problem. Anyone can start with whatever they want, but I recommend that you use the initial approximation to be the mid value. So I will say let the initial approximation be maybe alpha 1, which is going to be equal to 0.4, the average of these two, plus 0.5 out of 2, that is 0.45. Now alpha 2, that is the next one, then it will be equal to a half this equation they gave us here. Okay, here, so a half, then the natural log of 5, then out of 1 plus 2 times this one I've gotten here, which is 0.45. Okay, and then what do we get here as our answer? So you don't need to show every time that you are substituting in here, you're wasting time. Just show the examiner the first substitution, the rest just write those figures. Like this is alpha 3, alpha 4, alpha 5, maybe alpha 6, maybe alpha 7. We shall see whether we can reach this side. So what do we get here? Now I'll just come back to this one and I remove this first part here, and then I'll come to this one here, and then I put a 0.45, just like that, and then we get 0.4838, 0.4838. They said give each answer to 4 decimal places. Okay, so that is 4 decimal places. Then you get this one, you put it here. Don't come to this one and you say put answer. Sometimes that fails. Okay, in fact it fails. So what you can do, just put this value you have gotten, the rounded one, to 4 decimal places. Is that clear? All right. Now we come back to this and we put where there is 0.45, I'm going to put 4838. That one gives me 4663, 0.4663. We continue. I'll just come to this one and then I remove this is 0.4663. That's the one I put, and then we get 4753, 0.4753. We continue. Now when I round this one to 2 decimal places, this one gives me a 47, but then this one gives me 48. You see? So we have to continue. Come back to this and you put 4753, 753, then we get 4707. 4707. Now this one is giving me 47, this one is giving me 48 when I run to 2 decimal places. Now we continue. So I will come to this one here and then I put 4707. That is 4730. 4730. Now this one rounds to 47, even this one 47. So this is the minimum number of iterations I can do. Now I do one more to confirm. Okay, the third one confirms. So let's continue. I will come back to this and again we have 4730. So we have 4718, 0.4718. These three are giving me the same value, 0.47 rounded to 2 decimal places. So this therefore implies that alpha is going to be 0.47 to 2 decimal places, and that is that. Question 8 is coming from trigonometry part A. Express this one in this format: r is greater than 0, then alpha is in the first quadrant. State the exact value of r and give alpha corrected to 3 decimal places. Now we are going to use the compound angle formula, okay, to expand this one here. So this is cosine, then x, then plus pi over 4. You can check in the list of formula, you can find this, but if you are having this cos of a plus b, then you are going to have cos a, cos b, so cos x, then cos pi over 4. Then if this one is a plus, then here you have a minus, okay? So minus, then sine of x, then sine pi over 4. Now this whole thing is multiplying this 2 root of 2. You see that? Then we can continue. This one can give us 3 sine of x, then plus. This is 2 root of 2 cosine of x times cos of pi over 4 is 1 over root 2, or you can write root 2 over 2, okay? But I want to write 1 over root 2 because this one is going to cancel with that, you see? Then minus, again, 2 root of 2, because remember this one has to multiply everything. Then you have sine of x here, and also sine of 45 is the same as the cosine of 45. So now we shall have 3 sine of x, then plus, remember this one has gone, so we have 2 cosine of x, and then here this one has also disappeared, so we have minus 2 sine of x. Then of course we simplify the signs, then you will have sine of x and then plus the 2 cosine of x. Okay, then after that, I've already said that what you have here as the coefficient of, if we have a, then sine of an angle, and then plus b, then sine, cosine of an angle, okay, and we are writing it in terms of what? R sine. So we have this r, that r is going to be the square root of, you get this a squared, then plus the b squared, and put the sine here, and then we have x here. If there is a plus here, then here we shall have a plus. If you are putting it in terms of cosine and there is a plus here, then here you will have a minus, okay? Just like we have here, it's a plus here, but when we expand, we are getting a minus here. You see that? But they always help you, they put exactly what it is supposed to be. Then this angle alpha is going to be the arctan of, now you look at the coefficient of sine here, because you are writing it in terms of cos of sine. The coefficient of sine here is the one that is going to be in the denominator of your arctan, you see, like that. So that is what I'm going to have here. So I'll just say this one is going to be the square root of, there is a 1 here, that is 1 squared, then plus this one squared, okay, then sine of now x, then plus the arctan of the coefficient of sine here is 1, it is the one that is in the denominator, so it is 2 out of 1. And then we shall get, of course, a 4 plus a 1, that's a 5. So we get square root of 5, and then sine, then this will be x, and then plus. We write our answer here to 3 decimal what? Places, and the calculator has to be in what? In radians, because that is the domain given. So calculator in radians. So very important. My calculator here is already in radians, so I'll just say arctan of 2. Then it gives me 1.107. They said 3 decimal places, so maintain that. 1.103. So this is our final answer here. So some people are asking themselves, why do we do this one here? Okay. If you want, you can. you can expand. Okay, so let us actually do that expansion. So we have this sine of x here. Let me just prove to you that you just have to do this. But a person who does this right away gets the same marks as the person who is going to waste time with this. But let me show you. There are those that prefer expanding each and everything, and then they come out with the answer. No problem. So we have sine of x then plus 2 cosine of x. This one has to be written in the format r then sine. So let me even write here alternatively. So we have sine x then plus 2 cos x is equal to r sine. Then you have x then plus alpha. So using the compound angle formula, now when you open up here, you have r sine x then cos alpha. Again, r will multiply, so plus r, then now sine alpha, then cosine of x. Now from here we equate coefficients of sine x. So here we are having a 1, and then this side you cover the sine x, you have r cos alpha, not so? So we have r cosine of alpha. Then look at the coefficients of cosine. Here it is a 2, and then this side cover the cos of x. Then you have r sine alpha. So we have r sine of alpha. These are two equations which I can solve simultaneously. You see that? So what do we do? I know that sine over cosine gives me a tan. So I can have equation 2. I divide it by equation 1. So you have 2 over 1. Then will be equal to r sine of alpha. Then out of r cosine of alpha. Not so? So this will be a 2 over 1. In fact, let me maintain it so that you see something coming out here. So do you see that your alpha is equal to the arctan of this 2 over 1? That is exactly what we are having here. So the 1 here is the coefficient of the sine here. That is exactly what I've been talking about. Then let us see how the r now comes about. We have, you can square these two. If I get equation 1 squared, then I add equation 2 squared, we can have this one here, then is equal to r squared cos squared alpha. Then we have 2 squared, which is equal to r squared sine of alpha. I'm adding these two because we know that cos squared alpha then plus sine squared alpha is equal to 1, not so? So when I'm adding these two, I can actually factorize out the r squared. Then we have the cos squared alpha, then plus the sine squared what? Alpha. Do you see that? Now, do you see that your r here is equal to the square root of the 1 squared plus the 2 squared? Just these two coefficients of the sine and then the cosine squared, and then you put in brackets. You see that? So if you want to expand and then you do like this, no problem. But that is wastage of time. You can just do this. As simple as that. If you memorize this, then you're good to go. Part B, hence solve the equation, this one here, then for this range here. Now we need to go back here, and then we look at these two. This is theta over 2. It is in the place of x. You see that? Check the 2. It's in the place of x. Now, how did I come to this? Pardon me here. So we are going to have, already we have gotten this one as root of 5. Then sine of, now where there is x, I'm putting theta over 2. Okay? Then plus, the angle remains the one we got, which is 1 plus 107. Okay? Then we can equate to this 3, because this one was pi over 4. Even this way we were having pi over 4. So if we have put this one in this format, then we only change where x is, and then we put the pi over 2, as simple as that. Then our theta over 2 plus 1.107 then shall be equal to the arc sine of these 3 out of root of 5, not so? Then this one is positive, so sine, we know that it is positive in the first quadrant and second quadrant, okay? But now here, since we are having this one here from negative 720 to positive 720, it is better we first get 2 pairs of angles, okay? So how do we get the first pair? Let me draw something here. We have all are positive in the first quadrant, only sine positive, only tan positive, only cosine positive in the fourth quadrant. And then we are going to project an angle there, and also that same angle here. So suppose that angle is x, then also here x opposite angles are equal, okay? So to move from here up to here, that one will be pi minus that x. If this is pi over 2, this is of course 0, this will be pi, then 3 pi over 2, and then by the time you come back here, this is pi. Remember, when you go anti-clockwise, the angles are positive, and then when you go clockwise, the angles are negative. So we go clockwise in order to locate the angles in the negative region. In fact, let me take this one, this side here, something like that. Now, we have moved around the circle one time. For you to go to 4 pi, then you move around the circle 2 times, right? So this is 2 pi here now, plus the 90 here, that is 400 and what? 450, which is 5 pi over 2. Then you come to this one here, it will be 3 pi. Then here we shall have 7 pi over 2. And then by the time we come back here, we shall be having the 4 pi, okay? So we continue like that. Of course, this is your x, then this will be pi plus x. We are moving like this. Then this one will be 2 pi minus the x, like that. Just that is just for the first movement. Now we get the 2 values here. So we have theta over 2, then plus 1 plus 1, 1.107. So the first answer we are going to get here is in the first quadrant. But again, where sine is positive is in the second quadrant. So we say pi, then minus what we have gotten. Then to get the next pair, we can say this 2 pi, then plus this, and then this. You see that? So let us first get this one here. Now, pardon me here. I think when we go back here, there is a 3 here, and then this one is a 2. Not so? But then here we are seeing a 6 and then a 4. That means it was multiplied by 2. Not so? So I can have something like this. I don't know how this one skipped me. We can have this as 3. 2 out here. Then 3 sine of a half of theta. Then plus. This one will be 2 root of 2, then the cosine of this one is theta over 2, and then plus pi out of 4, like that, such that we get a part that is resembling what we were having before. You see, so what is inside here is the one here, okay? 3 and then the 2 root 2. You get that? So meaning we are having a 2 here. There is a 2 here. Like that. Because now if you don't do it and then you just proceed, this 3 here is greater than the 2 point something here. And sine cannot go beyond 1. Sine is always within this range here. -1 to 1. So you have to be very careful. So that's why we needed to first pull out these 2 here. Now that means when we bring it this other side, okay, it will be, there will be a 2 here, okay. In fact, no, I think I have also messed this one here. So we have something like this, twice of this, okay, then is equal to the 3 that is here, not so? Then that means we are going to divide all through by this 2 root of 5. You see that? This one will multiply with this, then you divide all through this side. Now let's proceed. Arc sine of 3 out of 2 root of 5. Then this one is giving us 0.735 and the rest of those figures. But since we are given, here we are having 1.107 is the 3 decimal places. The least number of decimal places I can have for this should be 3, but I'm going to take 4. 0.7353. Okay, this is 5, then 3. Then the next one is going to be pi minus that answer in the second quadrant where sign is again positive. You see that? That is the first pair. Now we need to get another pair. You should also know that now if I'm finding the value here, I will take this one this side, then I will multiply by 2 like that. Okay, so this one here, if we can get negative 4 or 4 times pi, what do we get? 4 times pi. The answer we get must be 12.6. okay, so it should not exceed the 12.6, somewhere there. This is positive 12.6. okay, now let us get another pair. How do we get the other pair? We have pi. By the way, to reach here, you can also move like this, then you come like this. You see that? Then now when you subtract off this one, then you come back this way, then times 2. So many ways to do that. Now the other pair is going to be 2 pi plus 0.7353, and then 2 pi plus, now this one you are having here, pi minus 0.7353. Remember, you moved one time, now you are coming back again, you are here, so now 2 pi then plus your x here. That's why I'm having this. Then again 2 pi, then come to this one here, you also add on this. That's why you are having this one, not so? Okay, so that is that. Then what else do we have? We can also consider, let us also consider moving like this, maybe up to here. Okay, there is of course where sign is positive, so we shall also consider this movement here. And then the other one is going to be, first of all, it is negative pi, because you are moving like this, so this will be negative pi, then plus this x of yours here. Okay, negative pi, then plus 0.7353. So I've gotten those are 5 values, so let me run with those. How can I get theta from here? Theta 1 is going to be 0.7353. I subtract this one, which is 1.107. Then after that, we multiply it by 2. Not so? We multiply that by 2. Then theta 2. Theta 2 will also be twice of this one we are having here, which is pi minus the 0.7353. You subtract 1.107. Not so? Yes. Then times the 2. That will be the second answer. Maybe the third one here is going to be again twice. Now we have this one here. That is 2 pi plus the 0.7353, subtract the 1.107, and then times the 2. Then maybe theta 4. We are going to have this one here. We have 2 pi, then plus pi, minus 0.7353, then subtract the 1.107, and then maybe the fifth one here is twice into, we have negative pi, then plus 0.7353, then we have to subtract 1.107. Now let us see what we get from here, and then we see what goes and what remains. Okay, now of course here I took this one here, but you can also go again like this, then you come up to the first quadrant, so that one will be also a negative angle. Okay, but let me first stop there and then we see 2 into 0.7353, then minus 1.107. This one is giving us negative 0.743, negative 0.743. I'll write to 3 significant figures. So this one here is within this range. Okay, so that one is okay. Then how about this other one here? So we have a pi in here minus the 0.73 whatever. So this one is giving us 2.60, 2.598 whatever, 2.60. This one is still in the range. Remember, this has to be the maximum. Then we come to this one here. We have 2 pi, so I'll put a 2 here. Then this one is a plus. There's a plus there. This is 11.8. This is 11.8. This one is also still in the range. It is not yet above the 12. Then we go to the next one here. We have 2 pi, then plus pi, then minus the 0.73, and then the rest. So that is 15.2. 15.2. So this one is off. But remember, this one here is coming from this second pair here. You see that? The second pair that we got here. Now, but this one fails. How about this other one here, which we took using the clockwise direction? You will excuse me here on this one here. Remember, we are going like this. So this is negative pi, and you are also adding on this angle here. So it is a minus also. So we are not going to have a plus here. It is going to be a minus. Is that clear? That's a minus. So that means even here, I should have that minus there. Now what do we get? So coming to this one, we are having negative pi. So I'll have the negative pi, then minus this, and then the rest. So we get negative 9.97, negative 9.97. Okay, so even this one lies within here. So that means I'm going to write down my 4 answers here as theta, which is going to be equal to negative 0. I can write them maybe in order. Okay, from the smallest, negative 9.97, then negative 0.743, then the next one is 2.60, and then lastly we have 11.8. These are all to 3 significant figures. Now when they are marking this one for every pair, okay, in fact they can give you 1 mark for getting this one here, then the other mark. By the way, did they tell us the degree of accuracy? No, they never. So you put the 3 significant figures in margins. So they give you a mark for the first one there, then they give you a mark for obtaining the second correct one. Okay, maybe this one here, and then they also give you a mark for other 2 answers which you get, like these ones we got. how we got them. We got this one by getting the 2 pi, then we add on, I think it was this one here. Then the next one where we got the 2 pi plus this one here, it never gave us, okay? But then there was also moving clockwise to come to this one. So the same way you move from here to here is the same way you move also clockwise there, and you get the negative angle. So that is the one actually that has given us this other value. But many of the students that did this paper actually never got this value, many of them. Question 9 is coming from vectors relative to the origin O. The position vectors of points A, B, and C are given here. Part A show that OABC is a rectangle. Now, we know that for any rectangle, we are having 2 parallel sides, okay? And they are equal in length, not so. So we have, maybe this is my rectangle. I'm just trying to sketch something small here. But I'm going to, of course, allocate these values, the points, but it doesn't necessarily mean that we are having those points in those positions. So if this is O, this can be A, then B, then C, okay? All of these angles are 90, okay? Now, if OABC is a rectangle, then OA is equal to CB. OA is equal to what? CB. So in fact, let me write that if OABC is a rectangle, then this vector OA has to be equal to CB, and also the length, okay? Then how about AB and OC? Also AB has to be equal to OC. You see that? Even their lengths. Now, since this one is 90 degrees, that means this vector here, OA, is perpendicular to OC. Not so? Then that means using the scalar product, we must get a 0. So using scalar product, vector OA times OC, what do we see? Is it really 90 degrees? So OA is 5, -2, 1 from here. Then our OC is 3, 4, -7. So what do we have here? 5 times 3, that is a 15. Then -2 times 4, that is -8. And then 1 times -7, you get a -7. Of course, this one is what? 0. And you know that if the scalar product is 0, then that means those vectors are perpendicular. So I can say that OA is perpendicular to OC. So that one I have proved it. Then next, let us look at OA. In fact, CB. Let us look at CB. Is it equal in length with this one here? So CB is going to be OB. You get OB, then minus OC. You just get the last minus the first. How does that one come about? If I have C and this is B, then this is the origin, then we put these arrows. All of these points here originate from here. So I want to find C to B. That means I will say CO, then plus OB. But CO is the negative of OC, not so? Then plus the OB. But usually we write in algebra the positive first, then this one last. So do you see that I'm writing the last, which is OB, then minus the first, which is OC? Yeah, so that's why I always say that when you are doing such vectors, you just say get the last minus the first. So what is our OB? It is 8, then 2, negative 6, then minus. What is our OC? It is 3, 4, then negative 7. So when we subtract 8 minus 3, you get a what? You get a 5, not so? And then 2 minus the 4, what do you get? Don't you get a negative 2? Then negative 6, then plus the 7. Because negative 6 minus 7. This one becomes a plus. And then you get a positive 1. So we are getting a positive 1 here. But you can see that this is exactly what we are having here for OA. Do you see that? So we have now proved that OA, okay, is therefore equal to the CB. So this, of course, means that the length of OA will be equal to the length of what? Of CB. As simple as that. You see? Then what else do we need to find? Remember, to prove that it is a rectangle, we need to find a scalar product of a pair of adjacent sides, just like we have looked at this one and then this one. So the scalar product is giving us a 0. Okay, so this one shows that they are perpendicular. So we also need to compare a pair of opposite sides. Okay, like OA here, is it equal to CB? Then AB is equal to OC. Okay, now let us also look at which other one. We have looked at C to B. Then how about AB? Is it equal to OC? So AB, just like before here, you get the last minus the first, not so? Last minus the first. The last one is our OB, which is 8, then 2, and then negative 6. Then we subtract. We have our OA, which is 5, negative 2, and then 1. So this one will give us a 3, then a 4 here, and then a negative 7. So do you see that it is exactly what we are having here as the OC? So therefore, our AB, okay, is equal to OC. So they are parallel. Okay, remember, parallel vectors can be expressed in terms of each other as scalar multiples. So AB is equal to 1 times this. It can be twice that, you know, they are parallel. Okay, equal vectors are still parallel. Okay, so, and that is that, I think. So I can conclude and say, since OA is parallel to CB and equal in length, because even for the parallelogram it is the same. They are parallel and equal in length. Okay, but this angle between the two adjacent sides is not 90 in the parallelogram. So that is what differentiates a rectangle from a parallelogram. And equal in length. And OA is perpendicular to OC, okay, comma, then what? Then OABC is a rectangle. As simple as that. Part B, use a scalar product to find the acute angle between the diagonals of OA, BC. Now, like we drew our triangle here. Not a triangle, it's a rectangle. So that rectangle of ours, here I'm going to draw the diagonals. Of course, these are not the diagonals, but the diagonals are these ones here, this one, and then that one there. You should know that the diagonals of a rectangle bisect each other. So this part here is equal to this part here, and then this one is equal to that. So this is O, this is our A, this is our B, this is our C. Let's say at the point where they meet is a D. Okay, then the angle between the two diagonals can be this one or this one. It can be acute or obtuse. Okay, then that is that. Like I said, the diagonals of a triangle bisect each other. Now we need to find the SC. Here it's a diagonal, and then also the OB, but OB we have it. So we need to find SC. So SC is going to be OC minus the OA. Not so? The first minus the last. Now OC is given here as 3, 4, negative 7. So we have 3, then 4, negative 7. And then OA is given here as 5, negative 2, 1. 5, negative 2, 1. So this one gives us a 3 minus 5, that's a negative 2. And then 4 minus minus 2, that will be a positive 6. And then negative 7 minus 1, that will be minus 8. Okay, here we can divide this one by 2, and then it can give us the DC. So I can consider DC and then the DB here. You see that? So that is our SC. Then what else? What else? Let us look at a half. In fact, DC is going to be equal to, I can even just take the SC and then the OB right away. So let me just leave that. And then we say OB. Remember, OB was given as, we have 8, 2, negative 6. 8, 2, negative 6. Like that. Now using the scalar product, I will have OB. When we are finding the angle here, you can either close in, okay, you close both, or you can open them up. So you look at this and then that. Okay, so we are going to have OB here. We dot it with the OB, then we dot it with the SC. So I'm taking this one here, I'm opening it up. Okay, so OB, then dot it with SC. Then this one will be equal to the modulus of OB, and then the modulus of SC, then cosine of the angle that is in between them. So by doing that, we are using the scalar product. Now we substitute. What is our OB? It is 8, 2, negative 6. Then what is our SC? It is negative 2, then 6, then negative 8. And then this one will be equal to, now the square root of our OB is 8 squared, then plus 2 squared, then times negative, no, it's not times, we're supposed to add. So negative 6 squared, then times, now the square root of our SC is negative 2 squared, then plus 6 squared, then plus negative 8 squared, like that, and then cosine of theta. So what do we get here? 8 times negative 2, that is negative 16, and then 2 times 6, that one gives us a 12, and then this one here gives us a 48. Okay, then this one will be equal to, what do we get in here? This will be square root of 64 plus 4. 64 plus 4 gives us 68. Then 68 plus 36, I think that's 104, because this is 64, then plus the 36, that's 100. Then and 4. And then what else do we have here? Then times the square root of, this is the same thing, eh? This is 100. Yes, I think we are having the same entries, 8, 6, and 2. 8, 6, and 2. Okay, so it's the same here, times 104, then the cosine of theta. Now here we have 48 plus 12, that is 60. 60 minus 16, I think we get a 44. So we have here a 44, and then of course these two multiplied will give us 104, then the cosine of theta. So that means that theta will be equal to the arc cos of, you first get to the 44 and then you divide it by 104. So putting this in the calculator, what do we get? We can give our answer in radians or in degrees, no problem. Did they say in degrees or what? They never said it. So you put it in what you want. My calculator here is in degrees, so shift, then cos, and then we have 44 out of 104. That is to one decimal place, then it can be 65.0. Okay, remember for non-exact answers, angles in degrees are given to one decimal place. You see that? Or I can give my theta in radians, but in the exam you write one. Don't write this in degrees, then you also say oh, then you also put in radians. Please don't do that. There is no time for that. So I'll change the mode of my calculator here, shift, then mode, then I put radians, that is option 4, then press equals again. So that will be 1.13. 1.13. This one is in radians, but it has to be to 3 significant figures, and that is that. Question 10. Let f of x be equal to this, where a is a positive constant, but a express f of x in partial fractions. Now, of course, if they give you partial fractions in part A, then the next part can come from either integration or binomial expansion. But we did binomial expansion at first, so this one probably has to be integration. But let's do this one here. This one is going to be 36 a squared, then out of, this is 2a. All of these ones in the denominator are linear factors. 5a minus 2x. So that means we shall say this one is equal to a, then out of this one, which is 2a plus the x, then plus, we shall have b, then out of the middle one, which is 2a minus x, and then c out of the 5a minus the 2x. Now this is our LCM. So this LCM here, okay, you are having the whole of this. So if you are getting the common denominator, it's just a matter of multiplying all of them. So it gives you this. Now you say the whole of this, okay, then divide by this one here. So this one will cancel with this, then you remain with these two here. Then you multiply with the a. You remember when you used to do, let's say a half, then plus a third, you say the LCM is going to be this times this, which is 6. Then you say 6 divide by 2, you get 3. Then 3 times this, then you write that there. Then plus, now 6 divide by 3, you get a 2. Then times this, so 2 times that. You remember those things? Okay, so that's exactly what we are doing here. So I said this 2a plus x disappears, and then we remain with this one here, which we shall multiply with the a there. So meaning we shall have a into this 2a minus x, then 5a minus 2x, then plus, you get this, divide by this, that means this one here, this one here will cancel with this, then you remain with this 2. So you multiply then with b. So b then times the 2a plus x, then times the 5a minus the 2x. You see that? Let me even extend this one here. The next, of course, when you divide this by this, that means this whole thing will cancel with this, and then you remain with these 2. So those are the ones you're going to multiply in C. And then you have 2a plus x, then 2a minus x. Then this one will be equal to the numerator here, 36a squared, because this whole thing is going to be over this one as your common denominator. But this same thing is the one that is here. You see that? So we cross this, and then we equate the numerators. You see that? Yes. So that is what we are having there. Now you look for a value of x that can terminate two terms here, and then you get the value of the other. So remember, our mandate is to find the values of these capitals. Okay, now we can say for x which is equal to, let's say, 2a, that means this one is going to disappear, and also this one will disappear, so I will remain with this one of b. Not so? So put 2a here and 2a here, that one will be 4a. Not so? And then put 2a here, that will be 4a. So 5a minus 4a, then you get an a. Then this side, you are getting 36a squared. There is no x this side, so you just equate to that constant. Now this a squared, of course, will cancel with the a squared here. Not so? Then you divide all through. You have 4a squared here. So when you divide in 36, then it will give you a 9. Not so? So our b is therefore going to be equal to 9. You see that? Then we can also consider x, which is equal to negative 2a. Why negative 2a? So when I put negative 2a here, this one can disappear. The same way this one can do. But then we shall remain with only a here. So what are we going to have now? Put negative 2a here. This one will be 4a. Not so? So we have the capital A and then the 4 small a. And then here, if you put a negative 2a here, okay, this one is now going to become a plus. So that one will be 4. So 2 times the 2a, that is 4a. Not so? So we have 9a altogether here. So there is 9a here, then is equal to 36a squared. Even this one is 36a squared, so that means our a is equal to positive 1. You see that? Then we can also look out for the next value. You can pick any other value you want. X can be 0, but still I can get this one here. You just get this one, you equate it to 0. So that means we shall have something like this, and then that will be 5 over 2 of a. So if x is equal to 5a out of 2, that means this one disappears, and then we shall remain with this one here. Not so? So put it here. Now we shall have c, then put 5a over 2. Get this 2 times the 2 here, that is 4a, then plus the 5a, that one will be 9a over 2. So we have 9a out of 2. And then how about here? We have 2a here, then minus 5a over 2. Get this times this, that is 4a, then minus 5a, that is negative a, then out of 2. Negative a out of what? 2. Then this one will be equal to 36a squared. And I think I messed here. This one must be 36, not just 3. Okay, then we proceed. That means our our c is going to be, this is 9 negative. I think this one will be a negative. So negative 9a squared over 4 of c, then is equal to 36a squared. So meaning c will be equal to the 36a squared, then times the 4. When you cross multiply, then you divide by negative 9a squared. So this one cancels with that. This 9 goes here 4 times, not so? Then 4 times the 4 gives you 16. So that means everything here goes to a negative 16 as the value of c, and that is that. So therefore our f of x is going to be, our a is 1, then out of the 2a plus x, then b is a positive 9, then out of 2a minus x, and then our c is a negative 16 out of 5a minus, I'm saying minus, then I'm writing a plus. So we have 2x here. Then that is that. Part B, do you see that it is coming from now integration, not binomial expansions, because we did it before. So part B, hence find the exact value of the integral from negative a to a of f of x with respect to x, giving your answer in the form natural log of, p natural log of q plus r natural log of s, where p and r are integers and q and s are prime numbers. Okay, just do the principles of integration, everything will fall into place. So we shall have the integral from negative a to a, and then our f of x here with respect to x, this one will be equal to, we are going to integrate from negative a then to a. The first one is, if you check, that is 1 over, it is here, 1 over 2a plus x. So 1 over 2a plus x with respect to x, then plus, again we are integrating from negative a to a. The next one is this one here, 9 out of 2a minus x with respect to x. Then the next one is actually minus 16, not so? So negative this one here to that, and it is, when we check here, 16 out of 5, 16 out of 5 minus 2x, then with respect to what? 2x, I think there is an a here. It is 5a. You know, you do a mistake in one, the whole thing goes. Okay, now let's proceed. When we differentiate this one here, we get the one here. That means that is a natural log. So we shall get a natural log of 2a plus x. Okay, remember, when you integrate and you see that what you are having up here is the exact derivative of what you are having down here, okay, then you get the natural log of that denominator. Okay, so that is what I'm trying to apply here. Now, how about this one here? When I differentiate this one, okay, I get a negative 1. But what should I do to this negative 1 to make sure that I get the 9? That means I'll multiply it by negative what? 9. Not so? To get the positive 9 here. So that means I will have this operation I've done on my differentiation is what I'm going to put in the natural log of the denominator. So I will have negative 9, then natural log of this 2a minus x. Or if you want, you can put this one here, and then you have something like this, 1 over, then the 2a minus that. You get that? So that is that. I'll take away this one here. Then we go to this other one here. When I differentiate, okay, in fact, let me put a plus here, then I take the minus there. When I differentiate this one here, we get a negative 2 when you differentiate the denominator. But what should I do to the negative 2 in order for us to get the negative 16? We multiply by 8, not so? Now this operation is what I'm going to write here, and I say that that is the 8 I've multiplied into this derivative, then it will be the natural log of the denominator, which is 5a minus the 2x, just like that. Okay, and then we can put our limits, because the limits are all the same all through. Then I'm going to put a here and then negative a, as simple as that. Then now we put our limits. So you put a wherever there is x, so we are going to have natural log of, that will be 3a, not so? A plus a. Then minus 9, put a here, so 2a minus a, that one will be a. Then the next one is 8, then the natural log of, put this one here, 5a minus 2a, that will be 3a, not so? So we have this one here. Then minus, now we go to the negative, so put a negative here, that will be 2a minus a, that will be an a. Then minus, now let us have this one here in here. So 2a minus minus a, that will be 3a, not so? So 9, then natural log of 3a. Then what else? We have put this one here. That will be 5a, then plus 2a, that will be 7a. So natural log, I think there is an 8, then natural log of 7a, like that. Then I will close, but all of these ones look ugly. So natural log of 7a, and then we close. Now I will extend this one a little bit here. Then we simplify. This is natural log of 3a, and this is natural log of 3a. So look at the coefficients. This is 8 and then 1. So when you add all of them together, you are going to get a 9. Not so. We shall get a 9, then the natural log of 3a. Then minus 9, then the natural log of a. Okay? Then we come to this one here. It is going to be the natural log of a, then minus. Is there anything? No. I think we just now open the brackets. So we shall have minus natural log of a, then plus, because the minus affects everything here. Minus, that will be a positive 9, then natural log of 3a, and then minus 8, then natural log of 7a. Something like that. Then we can proceed from here. We have 3a. You see this one here, and also this one here. So 9 plus 9, do you get 18? So that is 19, natural log of 3a. Not so? Then this is minus 9, then minus 1. That will be minus 10. Then natural log of what? Of a. And then what else do we have? Minus 8, then natural log of 7a. Now we are seeing an a in here, here, and here. So we need to pull it out, okay? Just like, remember what we are having here, okay? We need to simplify. So this is not the final answer. So now, since this one is a multiplication, okay? Since this one is a multiplication, then it comes from the addition of the two logarithms. So we have something like that. Then this is 10, then natural log of a, then this is 8. Then the same thing here, we shall have natural log of 7, then plus the natural log of what? Of a. Now opening the brackets, we shall have 18, natural log of 3, then plus 18, natural log of a, then minus the 10, natural log of a, minus 8, natural log of 7, minus 8, natural log of a. Then the ones that have gotten natural log of a, okay, we look at them. This is 18, then minus 8. No. 18 minus 10, you get 8, then minus 8. So that means natural log of a disappears. You see that? Then we remain with 18, then natural log of 3, and then minus 8, natural log of 7. And I think that is our final answer. So they said that we are putting it in, is it P, natural log of Q? And then the other one was what? Plus R. Plus R, then natural log of S. So you can see that our P is equal to 18, our Q is equal to 3, then our R is a negative 8, and then our S is a 7. Don't be confused. Here we are having a minus, okay? I can still separate this and I say plus, negative, okay? So these are integers. Integers can be positive or negative what? Numbers, okay? Now they said Q and S are prime numbers. Q and S. So Q is here. This is a prime number. 3 is a prime number. Even 7 is a prime number. So that is that. This is our final answer here. Then question 11 is coming from differential equations. The variables y and theta satisfy the differential equation. This one here. it is given that y is equal to 0 when theta is equal to pi over 4. Solve the differential equation and find the exact value of tan theta when y is equal to 1. Now, the first thing we do is to separate the variables. So separating variables, put theta on one side and then also y on one side. Now, we can do this by divisions and multiplication. So if we cross multiply, the theta will come here. Then we shall divide all through by this, then it comes to this side. You see that? So we shall have 1, then plus y here remains with the dy. But we can also divide all through by this, then it will come this side, not so. So we shall have e to the power of 3y. Then this one will be equal to, now when you multiply here, you cross multiply, the theta goes up. So we have the theta here, then we shall divide all through by this. So which is 1 plus the cosine of 2 theta. You see that? Then from here, using of course rules of indices, I can take this one up and then we can have something like 1 plus y. Then the power of the e becomes a negative, not so? Then come to this one here. I can, I think we have a dy here. I can write this one in terms of cos squared, okay? So we have the theta, then out of 1 plus. In terms of cos squared, it will be 2 cos squared theta, then minus 1. Now, do you see that the 1 is disappearing? So that means we are going to have 1 plus y, then e to the power of negative 3y dy, which is equal to, of course, separating variables, I ended here, but I'm just simplifying then to begin the process of what? Integration. This one will be d theta out of 2 cos squared theta. Okay, then now we can integrate on both sides, integrating. Okay, integrating, but then you know that this one is 1 over cos squared theta. We know that sec squared theta is equal to 1 over cos squared theta. Let me even just put this one here like that. So we are going to integrate this 1 plus y, then e to the power of negative 3y dy, which is equal to, now I have the integral of sec squared theta, then with respect to theta. You see that? Now, this one is a product of 2 functions, and we use an acronym here, ILATE. If you have been following me, I think you know this, okay? So this is inverse trigonometric functions, this is logarithmic, this is algebraic, this is trigonometric, this is exponential functions. But then when we look at these two, this is algebraic, which is here, and then we also have exponential, which is here. So which one comes before the other? It is the algebraic, so that is the one we differentiate. In integration by parts, we differentiate one function, then we integrate the other. So we shall let, okay, our u to be equal to this 1 plus y. So then we differentiate du dy, this one will be equal to 1. Then dv, we have always used dv dx, but this one is going to be dv dy, okay? Because the function is in terms of y, so it makes no sense now to bring in an x here. So dv dy is this e to the power of negative 3y. Now, when we integrate this one here to get our v, when we integrate an exponential function, we get the derivative of the power here, then we divide it by that function, okay? So when you differentiate this one, you get a negative 3, so you divide it here. So that is what we are having there. Now, we substitute in this one that when you integrate u dv dx, so I'll have u, then dv dy with respect to y. Instead of writing x, then I will write what? Y. Then is equal to uv minus the integral of v, then du dx. So I'll write du dy, okay? So this is integration. integration by parts. So remember, we use integration by parts if we are having a product of two different what? Functions. This is algebraic, this is exponential. Okay, now that means we are going to have u. Where is our u? Is this one here. So we have 1 plus y. Are we there? Then v is this one times e power negative 3y over negative 3. Then minus the integral. What is our v? Is e power negative 3y out of negative 3. Then times, what else do we have? Times du dy, which is 1. Then dy. You see that? So this is the integration of the left part. And then this one will be equal to a half. When you differentiate tan, you get sec squared. So that means when you integrate the sec squared, then you will get the what? The tan. You see that? Then plus an arbitrary constant, because we don't know what disappeared when they differentiated. So simplifying this, of course, we shall have 1 plus y here. In fact, I can write negative a third. Then I write the e to the power of negative 3y like that. Then this is a negative. It will give us a positive here. So plus a third. Then you integrate e to the power of negative 3y with respect to y. Then it's equal to a half. Then tan of theta. Then plus c. But you know that when you integrate this, we got this one here. Not so. So you have negative a third of 1 plus y, then e to the power of negative 3y, then plus, this is a third, then times negative a third, then e to the power of negative 3y, then this one is equal to a half, then the tan of theta, then plus c. Okay. Now we put the these values that are given here initially. Y is equal to 0, then pi is equal to, theta is equal to pi over 4. So if y is equal to 0 and theta is equal to pi over 4, by the way, before we do this, this is what we call the general solution of a differential equation. Before you find the arbitrary what? Constant. When you use these values and then you find the value of this one here, the arbitrary constant, then you get what we call a particular solution. So we substitute in here. Of course, this one will be negative a third. Not so, because this will be e to the power of 0, which is a 1. Then times this negative a third, because of course even this one is 1. So we have that. Then this one, of course, is going to be negative 1 over 9. Okay. And then e power the 0, so it is still that. Then here we are having a half. Then tan of pi over 4 will give us a 1. So that one is a 1. Then plus the c. So that means your c is going to be, bring this on this side. So you have negative a third minus 1 over 9, then minus a half. So c gives us, so we have negative a third, then minus 1 out of 9, then minus 1 out of 2. Then we get negative 17 over 18. Negative 17 over 18. So this therefore implies that we are having our particular solution as negative a third, then 1 plus y, and then e to the power of, this will be e to the power of negative 3y, then minus 1 out of 9, then e to the power of negative 3y, then this one is equal to a half, then tan of theta, and then minus 17 out of 18. They told us to find the exact value of tan theta when y is equal to 1. So when y is equal to 1, what will be our tan theta? So for y is equal to 1, here you will have a 2, not so? That means we shall have negative 2 over 3, then e to the power of negative what? Negative 3. When you put a 1 here. then minus 1 out of 9, then e still to the power of negative what? I mean e to the power of negative 3. Then I can put the 17 over 18 this side, and then I equate this one to a half of tan theta. So meaning, of course, we can simplify this because this one is common, okay? So we have negative 2 over 3, then minus 1 over 9. What do we get? Minus 2 out of 3, then minus 1 out of 9. So we get negative 7 over 9. Negative 7 out of 9 of e to the power of negative 3, then plus 17 out of 18. But now here, this one will be multiplied by 2 to give us the what? The tan of theta. So therefore, the exact value of tan theta here, I can write it as just this one here. Or if you want, you can multiply all through if you want. But that one is just enough. So it is that there.